this workshop, I'll just give you the structure of this workshop. So it's going to be about 10-15 minutes of just slides lang. Then I'm going to go into a Google Colab for the entire walkthrough. During the how do you say this? During the slide session, feel free to set it up. If you're going to into this URL here, you're going to be presented by this link here or this Google Drive. So what I want you to do is just open the notebooks, then just open one. Then you're going to have this notebook na to. Then just save it to your Google Drive account. Okay? So essentially that's the entire session. So there will be 4 notebooks for it. Then it will help you to set it up na din. So if there's going to be any issues in the actual notebook or when you're going to set it up, I'll go through the session after that notebook. Tapos may breakpoints naman. Then then I'm going to go around and help you set up if ever. Okay? So yeah, I'm also going to do another walk around para lang to ask after the 10-15 minute slide presentation. I'm going to go individual or go around if there are any issues in setting up or copying the slides or the notebook. Okay? Okay. Ready na? So I'll just go final for this one. So there's a there's an optional QGIS software here since you don't have the internet to access it or this software kasi medyo malaki yung software na yan. So I don't advise downloading it. So I'm just going to open that software then for you guys to see kung ano yung itsura niya. Okay? Ready na? Thumbs up na? Okay na? Okay na? Okay. So let's start. So welcome to this workshop. So the title of this workshop is From Maps to Models: An End-to-End Journey in Geospatial Machine Learning with Python. So it's going to be an end-to-end thing. So from data collection, processing, to building your own model. So let's get started. So yeah, I'm just going to reintroduce myself. So I'm Ian. So I'm currently an ML engineer at Open Solar. Essentially, it's a company that designs and sets up solar panels on rooftops in an automated manner. So just think of it as if you have a house, then you want to set up your own solar system or solar panel system. You go to your house, then it will automatically configure and set up that system sa rooftop nyo. So it's may halong ML, may halong manual for this one. So yeah, these are all of my credentials here. So if you want to reach out, I have my LinkedIn here. You can add me then if you have any questions and so on. Okay. So yeah, these are my past credentials here. So if you're into that, we can talk later about it. Okay. So yeah, so the agenda for this workshop is that you have, as I mentioned, 15 minutes geospatial concepts. Then let's build an hour for the workshop, hour 15, then another 15 minutes for the synthesis. I want to highlight here that this workshop is targeted for intermediate. Pwede siya sa beginner, but for purposes lang natin, we're going to go through it as an intermediate level. And I want to focus more on the nuances of geospatial data and how you process them. The Python bits here are not as the main focus because you can use large language models, ChatGPT, Cursor to build those. But I want you guys to have this first principles or foundational concepts before you start with geospatial data, especially with Python. Okay? So yeah, let me start nung slides. So the objectives for this is just to understand the foundational concepts of geospatial data, set up geospatial pipeline or the framework itself. Okay. So here are some of the concepts about spatial data. So you have all of these words, right? So a bunch of it would tell you that, okay, you have the world, you have some data on it, and it has a location. Essentially, spatial data is just data that has location. But there are some nuances to it. So what makes spatial special? So a lot of us here are going to come from computer science backgrounds, right? Or the difference between floats and integers and even doubles, right? But something that I want to highlight about spatial data is that one decimal point uh, error would yield you, it's either on the land ka or nasa dagat. So that's the difference of these two coordinate systems here is just, as you can see, almost same sila, it's just 0.0001. Up to 4 decimal places, it can either lead you to the land or nasa dagat or into death paminsan for this. So that what makes geospatial data special is that the nuances behind it, the context is really there. You don't treat it like just a number. Now, okay, 0.001 difference, right? In some machine learning models, 0.0001 is already good enough. But in this case, it's not good enough because you're going to be in the ocean. So when we think about spatial data, we need to understand when we build any machine learning systems, where did that data came from. So a lot of the data that we get are from land surveys, drone surveys, or even the GPS or satellite imagery. And I want to highlight here is that the way that the data that is collected affects how you want to process them. So for example, if you get your own phone that you get from let's say you get your location, it has an accuracy of 5 meters, around 5 to 10. Then that 5 to 10 meters can be good or bad depending on the application in use case. Sometimes for navigation, 5 to 10 meters is already fine. But for very specific application, for example, you want to design flood control flood control systems, that 5 to 10 meters is a very big factor. Right? So yeah, as I mentioned, ito yung accuracy niyan. So when you get into this machine learning system, then you get data, you need to understand where that data came from. Is it from a GPS using a mobile phone? Does it come from satellite imagery? Does it come from, let's say, survey-grade total stations or sa land surveys? So here are the list. So now I'm going to go into, from the accuracy, we now go into the data types. So when you go into geospatial data, you have two general data structures, data types. You have your rasters. So essentially, these are the, I think we're very well oriented with raster data. You have your images, right? So essentially, it's just an image. But for one pixel or one grid here, it tells you the coordinates. It has coordinates, and it has a certain value. Depending on the sensor, depending on the way it was acquired, it will tell you something. Then you have, of course, raster operations. I'm not going to go into this, but I just want to highlight that you can do all of the matrix multiplication, your raster operations to that. Then you have this raster formats. So again, these raster formats, it depends on the data that you're going to get. So raster can come from satellite imagery. It can come from interpolation. Let's say you get survey data from the ground, then you interpolate them. Then you have this varying raster formats. So some of these raster formats are proprietary. So you need special software to transform them into an image. Then you work from that image. So some imagery providers, they have their own special software. Then you pay license for it, kaya medyo mahal yung iba. So this is, I want to highlight about spatial raster in connection, which is the spatial resolution. When we say about high spatial resolution, it just means you have fine grain of detail here. So as you can see, you can distinguish the buildings, you can distinguish the roads, and so on, right? The individual, even rooftops. For a medium spatial resolution, you still can get a sense of where the buildings are and the roads. On the other hand, for low spatial resolution, you can have this. And I want to highlight as well is that for every raster or satellite data that you can get, they have their own resolution. So you need to be very wary on the application that you're going to use. For example, for open satellite imagery that you can get online, let's say from USGS or from the US, yung mga open data, they can range from 15 meters, 15 meters to 30 meters to even 3 kilometers. So you're going to see some of the some applications that is online, for example, flood or risk or traffic, they will tell you that this is only as accurate up to 15 meters. Kaya paminsan kapag when you go to your house, right, you try to assess, nababaha ba yung lugar ko? You're going to know, pag tinignan mo siya, when you look at it on the map, you're going to see it as, I'm going to be flooded, right? But note that it can only be as accurate as, let's say, 15 meters, that map. Then sometimes when you have this, let's say, an event or a flood event, for example, then pwedeng hindi kayo nababaha because of that nuance of this. So I want just to focus on that. Again, you have this. Then I want to highlight is that you're only as accurate as half of your data. So if there's a published resolution, let's say 30 meters, you're only as accurate as 15 because you can only be as accurate as half of your pixel. That's the. So next one is vector. I think you're very well familiar with vector data as well. Is that you have point data, points, lines, polygons. Let's say you're looking at grab, right? For example, my grab, you have 2 points. It will tell you a line where you want to navigate. So these are the vector operations. You have your various vector formats. And you have your what we call coordinate systems. Okay, so yeah. Just want to highlight for coordinate systems, they're not as focused of other talks, but I want to highlight here that you need to have the same coordinate systems as you want to be consistent in the coordinate systems. So for example, if you're going to get data, let's say in latitude, longitude, then you have data in meters, degree, let's say meters or kilometers. You want to transform it first and you do your analysis there. Okay. Again, which one to use? It's more of the slide here. So I just want to highlight this. This one, how do they differ? You're going to see online that most of that, we're very familiar with the latitude, longitude. The WGS84 for 326, Web Mercator 3857, all of those, for example, you have this idea of these numbers. But I want you to focus on, they need to be consistent. Because if you're going to, for example, if you're training a machine learning model, then all of your coordinate systems is in WGS84, and you have a learning rate of 0.001, let's say. That is only just 0.001 of degrees. You're only as accurate maybe 1 kilometer, 2 kilometers, 3 kilometers, right? But if you're into coordinate systems in meters, for example, the state plane or the Web Mercator here, then you can be as accurate as 0.001 meter, right? In a cm or millimeter even. Okay. Okay, so yeah, this is going to be the last slide for my talk. So we go to the workshop, to the notebook. So you have this, just want to summarize for all of that things that was talked about. You have this geospatial pipeline, which is you do your data acquisition. You understand your data, you understand where it came from, you validate it. What usually happens is you go to the field and get the data. You store it, you manage it, and you do your analysis, and you do your visualization and design. And you publish it through a map. Okay? So let's build na. So again, this is the QR code. So yung mga late na dumating, please scan the QR code, take a picture, then pwede mo siyang balikan. Then for the notebooks, go to the individual notebooks and so okay. So what we're going to do is actually, this is a project that I did, I think, 3 years ago, wherein we want to know yung river encroachment. So, for example, you have a river, ilang properties ang matatamaan given a buffer. Because in a real world scenario, if there is intense rainfall, your rivers get inundated. So, nagsispill over siya. And it will affect those properties. And sometimes, in national government, right, merong tayong mga laws and standards wherein you cannot build a property 3 meters, 6 meters, 10 meters from that river baseline mo. Yeah.
Andre, may mga na-observe ka ba diyang commentary from your side of the
Sorry?
room?
QR code again, sorry. Okay, yeah. Okay,
Ako,
QR code.
manalo. If you don't play competitively, babatuwang kayo.
Okay, final.
Pero may price to eh.
Okay, yeah. So in that river system, right? So that river system can be can affect those property. And it also affects the insurance. Insurance, if you're into that that your property is not risky because of flooding purposes. Okay? So they have their own models to do it. But for now, what we're going to do is a similar application. So a lot of this will be dummy data. So you can get data from your online sources and so on. Okay? So yeah.
Practice game lang ba yun? Practice game.
So I'm going to switch now to so I'm going to showcase first yung QGIS for this. So essentially the usual GIS person, what they will do is actually open sorry.
Dito muna kayo. Pag wala pang ano,
So let me just open up the data that I have.
Oh, sige. Meron bang may kulong na partner dito?
Okay.
Ayan, yung may kulang ng partner,
So
tumapat kayo sa isa. Ayan, magyan kayo ng bagong partner. Paubusan tayo dito, guys.
okay. So usually you're going to be so
May partner ka?
okay.
Tayo tayo. Okay, sige. Okay.
Let me just open this. So I'm just going to open this. So essentially what we're going to do is that you have a bunch of data and you're going to overlay them.
Pinapatalsik mo na agad yung ano eh. Madaya to, madaya. Okay. On this side, ready na ba?
Okay.
Ready na ba? Okay.
So I'm just going to open everything, okay? So just for you to have an understanding of. So as you can see, the map that we're going to build is that you're going to have, let's say, a bunch of properties from your satellite imagery. Then you have your river basin here, or a river, river outline. Then what will happen is that you're going to get the buffer from that river outline to the affected. Then you can implement, let's say, a very simple intersection of which areas will be affected. So as you can see here.
Okay. Okay, so ready na? Sige, mag-ano na kayo. Handa na ang inyong kamay. Ready your hands, guys.
Intersected
Ready your
properties.
hands.
So as you can see here, so for example, for a 10-meter buffer, this property will be affected.
5.
So, and something to highlight is that some affected properties are manufacturing or warehouses. So you'll have this additional nuance to the data that you're going to encounter. Okay. So yeah, essentially that's what we're going to build. So what usually happens is that you publish this online, then you have your government agency to do it. Okay. So going back to the workshop na. Okay, so essentially this is the Jupyter notebook that I did to explain the various geospatial concepts that we did earlier. So you can have a choice of going through this individual notebook here, but for purposes of the actual workshop, we can skip to that from that first notebook. So essentially, this notebook will just tell you what I have discussed earlier. So as you can see here, I can play the various. Sorry, let me connect. So it will just
Sige,
connect
sino
through
yung mga
that.
nahuli? Sino yung mga nahuli?
So it will just install
Huli
the
na.
various libraries that we're
Huli
going to do,
na.
that we're going to use. Then it will tell you
Okay.
the
Okay, so sino ang ano,
Google
natitira?
Drive.
Sino yung mga natitira? 1, 2, 3, 4. The Legends. Tama, tama mga legendary yung ano.
Legends na nakakaalam, no?
Oh. Sige. Atong dalawa na lang yung natira, no? Okay, sige.
Okay.
Sige,
So
sige
yeah.
na.
So what we're going to use is this library called. So there are a bunch of libraries that can be used for this. So for this workshop, so we're going to use LeafMap, GeoPandas, Rasterio, and PyProj. Rasterio to read raster data, to write raster data, LeafMap for visualization purposes, GeoPandas for vector data, and PyProj for coordinate systems. So, for example, as I've mentioned earlier, there are various geospatial points or properties that you need to look at.
Anong pakiramdam na kayo na
So,
natitira?
yeah. Okay.
Kabahan?
Okay. So, as you can see, it will install of the things that needs to be installed.
Ah, kasi nakapula ka. Tapos ako puti. Wow, galing.
So, if I'm going to plot this coordinates here.
Okay, tito.
Okay.
Anong pakiramdam na kayo na yung ano, natitira?
Okay.
Nung first round pa lang, kayo na, no? O, sige. Anong pakiramdam?
So, you have your notebook, then you can also do this.
Normal lang, relax.
You can pan it, you can zoom it, and so on. So again, it's a very good visualization tool from this, right? So you have your own data, then you can plot everything
Oh,
on the
relax
map.
na, relax. Okay,
So
relax.
again, I'm not going to go into the actual code, but in terms of the process, right? So you have your coordinates, then you just plot it on the map. It's a very simple workflow. Then, of course, if you're going to visualize vector data, what we have plotted earlier is vector data, by the way. So if you're going to plot this on the map, so once again, so we have two, these are the various vector data, as you can see. You have your point, you have your polygon, and you have your polyline here. Okay.
Mighty talaga tong dalawang tong. Galing.
Raster data similar case.
Ayan. So, dahil kayo
So
yung
it will again plot the map.
nahuli ka, may price pa rin kayong apat.
So I want to highlight something about raster data is that you have your boundaries, your resolution. As I mentioned about resolution, this is your spatial resolution. Your spatial resolution here is about 10 meters. So you're accurate up to the 5-meter mark. So as our concept earlier, you're good as half of your accuracy. Okay. Then, of course, if you want to display your raster data on the map, you can just, as you can see here, our extension is TIFF file here. Okay. So the raster data that we're going to plot, apologize, it's still slow, it's just internet. But essentially, it is a satellite data that is just overlaid on the map. I want to highlight that some areas of the world, they have poor spatial coverage or spatial resolution because they don't, the imagery providers, they don't publish that data. Or that data is highly classified security concern. So for example, we have issues in, let's say, the current wars, and you have your issue with, of course, the West Philippine Sea, so on and so forth. Right? You have those. But as you can see here, just using the notebook, it really tells you to investigate. So if you're not a GIS professional and know QGIS, right, you can use it Python, the Python way. And it's also a good way to play around with the data without actually learning how to use GIS. Just a show of hands, who knows how to use GIS here? Okay, 1, 2, 4. Oh, see, just a number, right? So again, you have this interpretation, spatial concepts. So suppose we want to combine raster and vector,
To assist Sir
the map.
Dominic for the session.
As you can see here, we are displaying raster data here plus the point on top, right? You can have other data as well. You can play around it. I think the main advantage of using this approach, using this Jupyter Notebook, is that you're not only limited to spatial data, you can also combine it with your ordinary tabular data. Then you can do your joins, all of your Pythonic workflows here. Then you can even actually build a dashboard if you're into that as well.
Second year taking fashion design
Okay,
and merchandising.
so spatial operations. So I'm not going to go into the spatial operations aspects, but again, the notebook is available, so you feel free to go around with this types of notebooks. Okay, go through the actual workshop for this. Okay, so yeah. Again, it tells you this. So again, it tells you, I even went into the spatial coordinates and resolution here. As you can see here. So, okay, I want to highlight again, in terms of spatial data, is that for 7 decimal places, if you round it to 3, you're off by 100 meters. So if you want to be very extra precise, which is 16 decimal places, you're accurate up to 0.1 millimeter, or this is nanometer, into that lower level scale. As you can see here, it tells you up to how accurate you can be. I think this is very useful, especially when you're designing your databases. And understand your application, because I've seen a lot of systems before wherein they're asking for a more accurate data set or accurate analysis, but what they have only saved is up to 6 because of they want to save spaces or file sizes and so on. So yeah, and we cannot interpolate beyond what is just provided, right? Okay. Okay. Everyone can follow so far. Okay pa naman. Okay pa. Are you guys okay? Okay. We can now proceed to... Okay. Okay. Maybe I'm not going to go through the individual notebooks, because you have already seen how to visualize the data, right? Vector lines. But I want to highlight here is that you can also view 3D data as well. So if you're going to combine spatial data plus, let's say, a certain frequency, you can do a join, then you can have this 3D act. So for example, this is in the United States. You have, let's say, some level of, let's say, frequency, or the, how do you say this? The, let's say, funding numeric that, okay, let's say in California, they are used to this. Okay, so you have your volume. You can also build your own, you can also draw. I mean, if you're into this interaction activity here. Yeah, I think it's very well provided. The notebooks, they are very well explanatory. But I want to highlight for this notebook is that it just shows the various ways that you can view and combine spatial data. And the workflow is just very simple, right? You have your data, you want to visualize it, you want to ensure that they are consistent. So, okay, I think this is what people are mostly want to hyper-focus is on the machine learning side. So, okay, do we still have internet? Let's wait. Okay, so in the geospatial machine learning world, data is everything. So I want to focus more on, after you have acquired your data, you now go into this idea of pre-processing. So for you to pre-process the data, your data, and analyze and validate them, is you need to have all of the concepts that I have discussed earlier. About you need to be very wary about resolution, very wary about boundaries, coordinate systems, the accuracy that you want to convey the communication set. Okay. So for this one, we're going to do is actually digitize the the raster data into them into a polygon, right? So as I've mentioned earlier, raster and vector data, they represent different things. So in terms of raster, it is represented by pixels. On the vector side, it's represented by points, lines, and polygons. And when you're going to process them, you need to have a way to unify them. It's either you convert your raster data into vector, or you convert your vector data into raster. Then you do your applications from that side. It's very hard to combine them, to do them, to simultaneously process them. There are some techniques that does them, but in terms of explainability, it's best to put one data format into a same format as you pick your poison. If you're going to work with raster, you do your pixel operations. If you're going to work with polygons, like points, lines, polygons, you're going to work with, let's say, the points, yeah, right? The vector operations. Okay, so let's load this. So yeah, going to load. So what the actual workshop will do is mostly you have your raster data, wherein you get your data from satellite imagery, right? You take from satellite drones, and you need to digitize them. Because what the objective is, you want to know how many properties will be affected by the river, right? The river outline that we've shown earlier. So I've shown earlier there's some properties that will be affected by if the river, let's say, just spills over a certain meter. And there are some systems that affect the slow. Okay, sorry, but so for this, I just want to highlight before I go into more details here. For notebook number 3, please connect it to a GPU because we're going to train a model. If I run this in CPU, it will take a minute to do one epoch. But for this one, just connect it to a GPU. Okay, going back. For this notebook here, we're going to do semantic segmentation. We want to highlight or digitize the buildings that will be affected by the river if it overflows, or how many properties will be affected by a certain encroachment. Okay, let's just reload. Do you still have internet? Okay. Yeah, we need internet. Okay, so while that's loading, so what we're going to do is that, once we have digitized them and we put them into our machine learning model, we digitize them. Then for every new imagery, because I want to highlight is that sometimes spatial data is very dynamic. They change throughout the years. So as an example, 5 years ago, you have this certain property. Then today, it is now a building. So you want to change or to identify that change through time, all right? So for our case here, so for our case here, for our case here, we want to add value or set it up such a way that you're able to get new data, then digitize them. without actually manually digitizing them. So because what usually happens if you're a GIS practitioner, what you will do here is something like this. You will go into your GIS, you toggle it, and you create your polygon, right? For example, you create this. You want to digitize, for example, there's a new building here, for example. Then you encode everything, right? So imagine doing this for 500 buildings, just one, right? So we have machine learning to help us do this thing. But what usually happens is that you need to get the data, the satellite imagery here, then you create a model out of it. Okay. So yeah, going back, so yes, you have this. Okay, want to close this. Wait, did I install the notebooks? Okay, code here. So let's just install the things that we need to install. Okay. So we're going to use a library called GeoAIPy. This is a very powerful tool to do. It abstracts a lot of geospatial machine learning properties or workflows. It's already a prepackaged, so you don't need if you don't know how to use PyTorch or set up a PyTorch model and so on, and you are a very learned or you know GIS and so on a little bit, and you have at least this one, it abstracts all of the things that you need to do. That does the machine learning, because what will happen is that you just need to run a few commands to create a model without actually building the architecture for this. Okay, so we have run them. Then we download the data. So as you can see here, okay, yeah. So these are the data sets that will be downloaded. So as you can see, it's already downloaded. Then, for example, you want to visualize the raster information of the data. As you can see here, it is a very big image. It's 2,500 by 1,126, so it's a little bit like landscape format. And the typical images that we work on, right, it's 512 to 56. Those are small. But once you're into satellite imagery, they can now balloon to 2,500. And some satellite imagery, they go into an even higher range, like 10,000, depending on the coverage. So yeah, it just tells you your statistics here. So there's also, so let's just visualize the vector data. As you can see here, we're also downloading some of the vector data. So you can get data from OpenStreetMap or Virtual Foundation, Google Open Buildings. There are lots of building footprints. If you're going to ask me, if you download data from these sources, you need to validate them before putting them into the main workflow. You do your due diligence. Check if the data fits, is the data updated, and so on. And if you ever find that some of these data are outdated, it's more of a small ask is for you to contribute it back to the community, because the people who digitize these data they're just volunteers. So it's a way for you to give back to the community. As you can see here, they digitize some of these building footprints here, as you can see, right? So for example, if I turn off the layer here, for example, okay, as you can see here, in some satellite imagery, there is no data or building data in this area, right? So if you overlay them, there are other building data because some of these sources, they aggregate the data from various sources or they use machine learning to generate. And if you're going to contribute it back to the community, please look at how to contribute because some providers, they don't allow for machine learned outputs. So because what they want to remove or to stop is that you corrupt the data, right? If you add more data to the mix, you're just adding noise to the data, which is also very bad. Okay? So what will happen is that this vector data, we're going to use them to do our training data. So as you can see here, it will create these tiles. So you have your semantic or you're building your, how do you say this, the building data that will be created into tiles. So the workflow is that we're going to convert all of the vector data into raster. Then we create tiles and you pass it to your semantic segmentation model, right? Or to train it. Your semantic segmentation model, it's just your standard semantic segmentation model. There's no secret sauce. If you were to ask me, there's no secret sauce to it. You can tweak the parameters specifically on the data set that you're going to get. Okay. So let's run this. Okay. Let's see. I don't want to refresh. Okay. So yeah, I just want to highlight the input parameters that you're going to use here. This is a very simple tile size. So for example, the training tile that you're going to put in for feeding into the model is 512 by 512. Then the stride is essentially just the overlap or just the shift because since we have a very big image, right? It's about 2000 and 2000 by 1000. You're slicing the image into 512 by 512 tiles and you want to do a certain overlap because if you don't put any stride or any overlap, some of the buildings will be cut. So it's very crucial that you have this stride option that sometimes you want to have an overlap of 30 to 40% or even 10% is already good enough. Again, it will depend on the data or the application that you're going to use. Because some application, they don't really care about the edges. They just want to focus on the center. You'll make certain assumptions that you work on the center. Okay, let's load. This is page. Okay, yeah. Apologize, the internet is slow. So yeah, so what will happen in that cell is that it will create those small training tiles. Okay, I connect to this. So we can look at the data here. Since we're having images. So yeah, this is a sample 512 by 512 image here. Right, so yeah, it was just cut into that. Then your annotations will be on top. Okay, going back. Yeah, yeah. Yeah, we're going to redo again. The internet is not just slow for a while. Yeah, feel free to run through the notebook. So while I'm running some of the cells, do you have any questions? I mean, for now, or is it still straightforward? Yes. Okay, no questions. Okay. Okay. Yeah. Let's just remove this. Okay, maybe we can just continue. So yeah, essentially what will happen is that you're going to train your model. As you can see here, we just point it, just fill in the details, right? You have your architecture, it's a UNet architecture, ResNet, then your encoder weights is ImageNet. Again, um, feel free to modify these parameters. But essentially what's happening is that once you've built your tiles, feed it into this model here, into this function call, then you're able to train your model for it. And you don't need to write a single PyTorch model for this. Then you run your inference, right? So once the model is established, you run your inference, then it will provide you this, the predictions of that, of this. So the yellow ones are the inferred or the outputs of your inference script. And I want to highlight is that it's not perfect, as you can see. There's some of some of the greens were not detected, right? So only the yellows were detected. So this model requires a lot more training, and that's true because we only trained it for 10 epochs. You can try training it for 100, 200. But what I want to highlight there is keep on training, generating new models, and just assess the accuracy. In terms of our accuracy, in terms of scores, as you can see here, it's still very big. It's still zero point 0.1 to zero point 0.8. It's still high. If you have more time, train it to a longer period. Then what will happen is that you have this, yeah, you do this inference. Then you have your buildings available. Then use that to do your inference, your analysis for the river line. Then you do inundation. Right now, do you have any questions? At least for this one. Yes.
I'm just new to AI. So I would like to understand when you say you train the model, are you basically seeding the different raster images? Or how do you, when you say I'm training the
Okay, okay.
model?
So what's happening is that you have your annotations, right? The buildings that you draw. Then what's happening is that you're telling the model, given this image, these are the buildings using the annotations that you have set. That okay, these are the buildings that I want to detect. Okay. So essentially, you're teaching the model. You're training them to be building detectors or building segmenters. So you are essentially teaching the model to, okay, this is a building, or these are the areas of interest or objects of interest that I'm concerned with. Then if there's new images that comes into your way, your model will be the one to tell, okay, this spot here, or this set of pixels, or this set, or this area here is a building. So you're just telling your model to do that, or training it.
So is it similar to the computer vision?
Yes, yes. It's essentially it's computer vision. So it's the training is more of it's just a generic term that can be used for computer vision, NLP, and so on. So you're just telling the model that these are the set of objects that I'm concerned with, that any new images that in the future can be, you're telling the model that, okay, detect the buildings.
So in the beginning, right? So you mentioned a while ago that I can have one raster, right?
Yes.
And then that raster images contain several buildings.
Yes.
And that's fresh. You haven't annotated it.
Yes.
And then
In some
when you say
way.
annotated it, you can use the GCIS, right?
Your GIS, you to draw them. Yeah,
Then
you draw them. You
manually
draw.
it.
Yes, exactly.
And then the benefit of doing the training is that it would automatically
Yes,
detect.
you don't need to do that 100 building
So
drawing.
you're just gonna do the sampling.
Yes,
On
you
the
can tell.
sampling
Yes,
annotation.
yes.
And then you feed that to the wonderful
Yeah,
AI
yes,
libraries in Python.
yes,
Then it would automatically detect. And then
yes.
the resulting here
Here
is the yellow page.
yes, yellow tiles.
And then it did not detect the green one because it needs more training.
It needs more training, or it needs more data,
Data.
or you need to modify some of the parameters. So it's I cannot pinpoint one one workflow that you need to test out.
And then this one would be the one just later to the flood.
Yes, yes. You're going to put these things into that. And I want to highlight as well, in spatial, in a lot of imagery providers, they they function differently. So for example, we got this data, this raster data from one imagery provider. You're going to build a model out of it, right? The assumption is that the output of that model can be used to another satellite imagery. And most of the time, it doesn't follow. So you need to fine-tune that model. So think of it as a large language model, right? Your large language model, they are trained on English, but it doesn't know Filipino. Similar to satellite imagery, it's trained on uh, open satellite imagery. For example, this is a very specific one. If you provide it with another satellite imagery for, let's say, the Philippines has its own Philippine Space Agency. They produce satellite imagery. But if you use an open model, or let's say an open source model, then you use that, it may not work. Because you need to tell that model or fine tune it that this is a new set of imagery that you need to do. So, and you may need to do the annotations manually because the data is not yet available or that data is outdated, so on and so forth. Okay, any other questions? Okay, go ahead.
How would you usually verify like the segmentation is correct in this case?
So what will happen is that you have your satellite imagery, right? You overlay them, overlay them, then that's why it's a little bit hard to do a validation for vision models, especially specifically for this one, because you need to manually check them. Yeah, exactly right. It's very hard. You can build an agent that does validation, right? But it's a whole new process or whole new workflow that needs to happen.
So, you,
Go ahead.
so I presume in your usual day-to-day, you usually would just manually verify, or it depends.
It depends. So the workflow is I look for the scores. I do those scores. Then what I usually do, lost scores, right? Then the next step is I create a blind test data that is also manually that was annotated. Then I implement an IOU wherein it intersection over union. Essentially, you have your inference, right? Then you have your manual annotations by the person, by humans. Then you just overlay them. You use your intersection, you use your union vector operations that I've told earlier. Then you compare the geometry, how it looks like. Then that can be automatically done.
So, if I understood correctly, you're comparing like manual annotations versus the
Inference.
AI
one. You can do that. Um, the challenge is for future images, right? Because that data is not necessarily annotated. So what will happen is that you need to manually check them. So yeah, that's the hard part about spatial data. And I want to highlight is that 80% of my work is just digitizing, checking it. Only 20% is just building this. Because as you can see, we've already built a model with just few lines, right? It's not even 100 lines there. It's just you have your data, the library does everything else, then you have that. It's already available. And I think the good thing about spatial data is that it is still a vision problem. So your vision architectures also work. They just have a little bit of a nuance because a lot of pre-trained models were trained on non-spatial data. So you need to build this training data. As I think it's also mentioned earlier, right? Wherein a lot of these models, they were trained on English, but once you put in Filipino or specific Cebuano or Ilocano terms, it already fails. Similar to spatial data, you'll have that nuance because a lot of these trained models were just were built not using spatial data. and they were trained on cats, dogs, humans, and so on. Okay. Yeah. So yeah, essentially that's the entire workflow. So there's also another notebook here that does the synthesis. Okay. Essentially, so I'm not going to run through all of the synthesis, but I want to, yeah, I'll just go through the notebook. But essentially, that's how your end-to-end model. So we started with the map, right? We started with what we want to achieve. Then we deconstruct it. We understand that, okay, some of the data is raster vector. Then from that, you put them into you train a model, you build a model, then you use that to build other aspects of it, or the inference. So as you can see here, so yeah, I'm not going to go through the individual lines here, but as you can see, so this is, again, we just try to build a very simple, so the river, as you can see, the river line is just down here. But the general idea is that this river line, you create your buffer. Then from here, you build a model that will detect that we built earlier, right? Then what if there's a new satellite imagery that you want to test your analysis, because what you only have is just the river line for that area, right? You don't have the annotations or the buildings from OpenStreetMap. You look at OpenStreetMap, you look at Overture, Google Open Buildings, you don't have those. Then you only have the satellite imagery. Then you can use your existing model to generate those buildings, and you do your analysis from here. So as you can see, we run the model. Yeah. So yeah, as you can see, it will tell you, yeah, it does scoring. As you can see, it tells you if it's high risk, low risk, medium risk, similar to your flood hazard map. I think, so, let's say a Project Noah, right? You have your high, low, high, medium, low risk areas because of certain characteristics. It's also a similar foundation. The main challenge here is the data. There's also a different way to do it, is that instead of buildings, you can also do it for river lines. What if there's a new waterway drainage? You can also do a reverse. You want to annotate all of the waterways in the Philippines. Then from there, you're able to detect, okay, this property here will be affected by floods and so on. And in the future, right, or in, let's say, in terms of planning and so on, you have this new data that comes in. You want to assess whether these data will be affected, or these properties will be affected by a certain river system. Yeah, CRS, yeah, as you can see, it's just a bunch of code. I apologize, I'm not going through line per line, because if you're going to ask me, it's a pretty much straightforward workflow. The focus is on the foundational concept of the spatial data, right? The conceptual aspects of it is that about resolution, about raster versus vector versus the actual outputs, because your actual outputs is affected by the first assumptions, that way that you gather your data. And most of the time, the problem is not the algorithm, it's actually on the way that you gather the data. And sometimes it's very hard to explain, especially when you're a data scientist, you're coming in from a data scientist point of view. You're going to ask, why is the data wrong? Or why is my output wrong? And I've seen a lot of times the problem is not actually their workflow. The problem is the way that they gathered the data, that they made certain assumptions, or the typical data science workflow, right? We're in, okay, what if there's some interpolation, there's points, right? There's points or polygons, and there's some missing data. Sometimes what you usually do is try to interpolate. But if you interpolate, that point will be on the sea, which is which is outside, right? Once they put it into the model, it produces a erroneous result because of that certain assumption. That's why the issue with spatial data is not so much on the algorithm, it's more of the data acquisition side. And it's very the taxing, how you say this, the problematic part, cannot be done by you. It's on the data acquisition team that needs to handle them. Okay, do you have questions? Do you have other questions? Raise hands. No more questions. Okay, no questions, no questions. No questions. So do you have questions?
I guess I'll ask another question. I guess for everyone's benefit slash my benefit as well. And he said, oh sorry. I guess I'm not sure if like it's a full rep, but like, as you stated, right? Like it's more of like a data acquisition problem. It's not really like models in general. So like I'm curious of like how would that tie in into like a beginner's perspective? Like how would you how do you say? Like how would you get started in like geospatial related projects if it's more of like problems relating to like just data itself? Like
So,
how would you essentially figure out like a project to work on to get started?
so a friend of mine, who, he did his thesis on basketball court vision because it's something he likes about. He made the thesis. So what he did is that there's a vision, there's UAAP games, I think. So what he did is that from Studio 23 back then. So he downloaded all of the YouTube videos from that. So what he did is before there's no in the Philippines there's no shot chart, right? Wherein okay, this area, this part here is this person, this player is very hot at these regions. So what he did is actually try to digitize first the court and try to infer that visual point of view into that. So the cameras, they're just static there. So he's very curious about, okay, how a certain team, before he is, I came from UP, so he is focused on the UP men's basketball team back then. We are 1-17, something like that. So he wants to understand why the team is very bad. But the general idea there is that he found something that he is very curious about and close to his heart because he really likes basketball. He knows the stats of the game, NBA and so on, but he's curious about it. So look for something that you're very curious about that you can relate to. I did a project before wherein, okay, some of my, in our GIS class, wherein the team or the group are doing um, in the Filipino, di ba, parang palagi, we're always asking where to eat, similar to what we did earlier. Are you hungry? Similar to that. And that group, what they did is that there's no Google Maps back then, or so what they did is actually try to look for food vendors in the university, and a lot of them are underground because they're not legit. They're just bahay-bahay, karinderya lang sila, right? So they go through that community. Then what they did is just they have a phone, get the GPS point, right, of that. It's okay if it's not very accurate to the millimeter, because it's okay, right? If you're accurate up to 5 meters, that's fine because it's just there, right? So the point that I'm trying to make here is look for a project that you're very close in doing, that you care about, that doesn't require this much, right? Whether it's just food, whether it's
Thank you so much po
um,
for
basketball, sports,
very
go for that because the main power of spatial data is the domain experts that you
Bakit
do
muna tayo?
with it.
Kamustahin muna.
Spatial data is only the foundation layer. If you have something, because that person, my friend is he knows about basketball. His domain expertise is not only spatial data. His domain expertise is basketball too. So if you combine those, then you're going to be better. Similarly, if you're into food, right? Okay, my domain expertise is not actually just placements, spatial data, and so on, but I know where to buy the best food. That's your domain. So you combine those, and you're going to be, yeah, you're already in that good sense for this. Okay, so since I still have, okay. Okay, yeah. Okay. Okay, so yeah, this is actually in tying to that, right? So as of now, you're going to be coming like a specialist, right? Um, so I'm a geodetic engineer by trade. I'm not a computer scientist, okay? But we had, I think, 7 programming subjects in geodetic engineer. So we're surveyors. We set up an instrument, we look at stuff, we measure distances, elevation, and so on. But I really like coding. I don't like working in the sun. Actually, I like. I'd rather have a person fly a drone, get satellite imagery, than I just process the data. I'm not into okay, go to the field, set up the instrument, but I can do those, right? So my starting point is just a specialist. I know spatial data. Then I learned how to use my first programming language is actually Visual Basic and Java. Python, I only learned about it 2013, 2012. Back, but that's already 14 years ago, around that time, right? So, but I really like coding. I really like. Then I ventured into that. I studied data structures. I studied this. Then I learned already 2 steps, right? I now have a little bit of a broad general knowledge in computer science, at least, or a developer point of view. Then I'm now learning as a energy engineer. No, no, no. So I'm still an ML engineer, but for an energy company. So I learned about solar, renewable energy. I learned about oil and gas, how they're drilling, um, how they extract oil, and so on. Then I have some idea now on, okay, what if I combine spatial data with energy with software? Then you're going to do that thing. But you start with being a specialist first. You don't jump because a lot of people are jumping. They want to do everything. It's very hard. Especially right now, software is very easy to do because of large language models, right? But the challenge there is how do you know whether the output is good or bad? So for you to have that, you need to have this foundational concepts, first principles. Then once you have that, it's very easy to translate it to another concept, to another field or industry. Because at some point, you're going to be like a comp developer here. You're going to have a lot of topics, a lot of um, expertise or specialization. And from that, then you're going to be better suited as a programmer. That's why it's some people are more into a broad. They do a broad um, scope of what they're doing. Then they just build up stuff. Right? So essentially, those are the things. So we can do more open discussion if you have questions. So it's about 2:30 now. Okay.
Yeah, thank you very much for I got
I got a lot of insights today. So my question actually, so right now you spend time on the geospatial, but I think the idea is that it could also use for other things because it's like a computer vision. So I could see it from medical
Yeah, yeah.
imaging, and then I could see that also on electronic
Yeah.
circuitry. I could see that also on insurance
Yes, yes.
during devastation. So I'm seeing a lot of cases.
Applications, yes, yes.
And then my question now is that I'm new to Python. That's why I joined here. So you mentioned the different libraries that you could use, right? Is it safe to say that for every use cases, there are a very good Python libraries that you could just, let's say,
Yeah.
ask about in AI?
Yeah.
So, like for example, let's go for electrical. So that's the schematic. You just basically have a raster image of a circuit board, and then
You digitize
from
them.
then you train it like the spatial, right?
Yeah.
Is this the same AI that you presented?
Yeah,
The same thing
it
with
can
what?
be. Yeah. So think of it as instead of. I mean, I relate it back here, right? Instead of let's say circuits, right? You have wires. Think of it them as road networks. Yeah, you have that same principle. But the foundational concept there is computer vision, right? You do computer vision, they're just lines, polygons, points, right? At the end of the day, they're just that, pixels. Then you deconstruct everything to those. Then you'll have that broad understanding. I can apply this to medical, I can apply this to electrical engineering or some other. But it's something that you have to learn as a domain because I've seen a lot of since it's now easy to do this in large language models, right? In your chat GPTs, they tend to produce products that give a wrong impression or they communicate problematically in the general sense because they didn't have the appreciation of the foundational concept about spatial resolution, for example. For example, you don't know about spatial resolution. You know that, okay, I have data here that come from the internet, I used it. Then it will be shown to an LGU, right? Wherein that LGU used your data to plan. But that data was not validated or that data have some issues because they used a very inaccurate instrument. I mean, for the sake of argument, they didn't know, right? You don't know. You didn't know. Then they use that. And someone may die because of that. Because you communicated it like this is very accurate to a pixel or to a certain meter. Then you're going to have that issue. So that's why I'm very wary about going into a specific domain without understanding the first principles of that domain. So because I've seen developers, I mean, in general, right? In software development or in just or simple product, is that they produce a product and they made certain promises to the just going to say to the LGU, but they were not able to deliver it, or they were able to deliver it, but they were not used because it's not applicable to their use case. And you don't want to have that because you're just wasting effort. So don't stop. That's why when you're going to start, if you're just starting, go for something that you really care about because you're already a domain expert of that. It's very easy to have this idea. Okay, okay, I built a model, I built a product, and I'm the primary user of that. Since I'm the primary user, if I did not make it good, most likely I'm the one who will be affected, right? Not another person. Then you're the one who will QA it, quality check it as well.
Do we have any more additional
Okay, questions? Open discussions. Okay. I apologize. I am very fast in this workflow because again, the notebooks and the links are already provided, and you can ask ChatGPT for it. You can ask Claude. Before, when I was giving this workshop, I'm doing it line per line, and a lot of people have and a lot of it's very easy actually to do it in a local setup when you're doing it on your own without having I'm not rushing, for example, or in not a very time constrained manner. But so it's very easy to ask ChatGPT, Claude, Cursor, all of the large language model to what the code means. And it's not, yeah, it's very easy to explain using that. At least it's in your own time. Yeah, other questions? One second, if we have questions.
Hi, in line with what you said earlier, I'm not sure if it's quite related to the topic, but you mentioned about how things could be dangerous given that it's not entirely accurate. Um, there, I'm mostly relating to this to like, let's say for example, maps, the ways or Google roads or whatever that drivers use. Oftentimes there are roadblocks or broken structures, right? It's not often reflected in the maps that they're using, and that is quite dangerous. I want to better understand how often does the data need to be updated or validated, or even if, let's say, for example, it's too costly to update.
Yeah.
What can we do to provide some sort of fine print to
Uh,
show people that hey, this could be uh, like what we have right now could change in the future, something like that.
okay. It has, I think 2016, 2015, 2016. It has a similar feel to it wherein there is Google Maps. They're using Google Maps on navigation. I think I forgot if somewhere in South America. So what they did is they're following the navigation of Google Maps. What they didn't know is the contextual aspect of it. Or they're foreigners, so they went to South America. They just ride their car. They just rented a car. Then they use the navigation. Then it put them into a very dangerous neighborhood. And I forgot if they were hurt or some of them were killed because it was not presented. They tried to provide Google, and not just sue Google in that regard because it's you just follow the map, right? And Google only represents the physical aspect of it. They don't understand the context of those neighborhoods, some of those neighborhoods or some of those issues. So in terms of how do you communicate it, it's it's very hard if you're a technology company. Sometimes you just want you are you are only focused on the technological aspect. You can only provide them, okay, I'm accurate up to 1 meter, 2 meters, because that's the physical world. That's why it's very important for a technology company to have this context. As I mentioned earlier, you have this contextual aspect of that physical world. And sometimes some technological companies would add more data wherein, okay, what constitutes a safe neighborhood? You can include those. Some organizations, they also add more insight or context to the product that they produce. So if you're a product developer, you need to understand where the nuances are about your data, about the product. Then from there, you can provide a disclaimer. Okay, this will change over time, or you just keep on getting more data, or you have your AI model to do the to do collision avoidance, for example, or so. For example, in self-driving cars, if you're going to think about it, the Tesla FSDs, they just incorporate the nav system into the model, but they don't follow it directly. But they incorporate other sensors, camera, radar, and so on, because they know that the map is in itself a little bit static because you cannot have self-mapping the entire, right? So what they just do is incorporate additional data from the world, let's say vision, a camera, radar, all of these things, to put into the model wherein, okay, this, based on these sensors, it is safe to go through. Based on these information, which is a little bit real time, let's say 1 second delay, 5 second delay, it's already good enough for the model to decide this is a good enough way to provide to push forward. And I want to highlight as well is that it's very dynamic. Unless you cover the world with CCTVs or sensors, all of those, you build that, wherein you're able to monitor everything that's happening on the ground. Then you build a model out of it. And that's what they're now into, the smart cities, digital twins, all of these things. But they're very costly. um, so I went to a Phosphor-G conference, I think 2 years ago in South Korea. So they did build a similar digital twin, wherein for every corner, they are able to monitor traffic flow, they're able to monitor shadow, noise, temperature, heat heat island conditions, all of these things. They're able to incorporate it into this world model we're in, okay, and put it into, let's say, a map or into a digital twin, into this interface we're in. But given all of these sensors, there's still some accidents that happen because apparently they did not account for driver psychology. Some people were drunk while driving, right? You cannot really avoid it. And the hard part is just the psychology of a human being. It's very hard to model, right? So yeah, that's what's so yeah, going back, right? So you need to be very in terms of the product, you need to be very clear on what it can and cannot do. For me, I'd rather be to have a more transparent product versus a product that's just okay. It will tell you later, right? So yeah, okay, go ahead. Yeah, thank you.
Yeah, sorry, I have a follow-up question related to that. So we have this data and we do get these models. There are some cities that implement this CCTV world. Um, do you think that the Philippines would be capable of having a more realistic output or like more centralized data? Because based on like just for example, based on the talk earlier, majority of the LLM models are trained around the Western culture, around like American culture, and I'm assuming that the data that we also get for spatial is also related to that. Given that, do we have enough in the Philippines to truly and accurately map out, let's say, for example, the the roads, the typical roads that we have here that cannot be found in
Uh,
Western data?
I don't want to rant so much, but I've worked with government before. Something that I want to highlight is that you need to change the culture of the people who are building, or because there, a lot of data can now be automated, right? You can get sensors, you can get CCTVs, whatever, right? You can how do you call this? You can you can grind out, put every let's say square kilometer or square meter as CCTV. The challenge really with at least government or Philippines in general is that the culture of being to share data and being open about it. Um, so the challenge is that when you go into, let's say, a government agency, they want, let's say, I did a project before wherein we're just monitoring traffic at Katipunan stretch. So what we did is we just want to know at 6 o'clock in the morning to 7, so that's the rush hour, right? Or 8. How many cars are in Katipunan? So essentially, you see traffic enforcers or MMDA, they're just counting cars, right? For every lane, so on. They have they have paper for that. They tabulated that. It took us 3 or 4 months to get data just for a project. Yeah, just for a subject, just a project in the Philippines subject, right? It took us 4 months because we need to go through the proper channels. It needs to get a letter. You need to give it to the head and so on. So that that setup then it's very hard because they're not very open about providing you data. The reasoning behind it. So I've also worked in government. The reasoning behind it is that they don't trust their citizens that they're able to understand the data. They don't trust their citizens to properly know what to do with the data. Um, because at the end of the day, they're very fearful of if a certain citizen or a Filipino use that data to commit harm, they're the ones who will be on the receiving end. And it's a little bit sad because you have this accountability, they're fearful of that. So yeah, going back to that scenario, you need to change that culture or having this open data uh, mentality. Not necessarily open data, I mean, everything is open. You can anonymize it, you can all do all of these things. It's That's the culture side. There's also the infrastructure side of it. So when I talk about infrastructure, I'm also talking about the processes inside this government and inside the Philippine government. Because the people who knows the data inside government, they're very few. So I had a project with DOE before, Department of Energy. So way back, wherein they're the people who are handling the data, they're also doing other things. They don't have enough manpower. They don't have enough people inside government to clean the data, to make it, to upload it into a Google Drive. I mean, if you can you can even just have a Google Drive link, then that's fine, right? But they don't have that mental capacity to do it. So it's also that's the infrastructure problem. So you have both ways. You have the cultural problem. You have your infrastructure because these people they're not paid overtime, right? So they're just paid to do a certain task. And if you add another work, then they're more apprehensive doing the work for data. So that's why when you're going to build products for government, you need to understand their workflow. And please don't add additional work to them. Try to remove work, then try to help them do it. Because I've seen a lot of new software that are being deployed in government that adds work. We just automate. They do the manual thing, they also do the digital thing. Right? It's counterproductive there. So try to remove, it should be removed and something like that. So yeah, you have those two aspects. So in the foreseeable future, it's very hard because you need to change culture. The infrastructure side, it can be done, but if the people who are in power will not provide you or the culture is still there, it's not going to happen. That's why we do this community. It's more of a community thing, right? Wherein you want to educate people. You want to educate people who are in the field or like us, right? We're doing this community engagement wherein you're able to help to spread the knowledge of okay, maybe if we're able to provide open data, we're able to provide democratized knowledge, then it's a one step closer into having that. But as of now, it's very hard, right? It's challenging. Um, yeah. Some departments are very open about it. I think the OS is it's a good example, and I think let's say mapping community there also. But yeah, it's there. The challenge is there. Okay. Questions? Okay. Questions. Good. Very good. Sorry, okay, I think we're good na. We're good
Any
na.
other questions?
We're good. Okay,
Going once.
okay. Alright, final question? Oh, sige.
I guess for like my last question.
Ah, so fine, fine.
Maybe that you think was solved through this year's geospatial data? So like there are a lot, like there's like poverty mapping, house predictions and stuff. So like any random top three that you think is like interesting personally
Okay.
for yourself.
So, for example, ocean renewable energy. So that's just a top one, right? That because I did a project before in the university in DOST. It's a DOST funded project wherein you have your because in the Philippines, to cite some numbers, we're only about I think 40 or 50% cloud free. So solar energy is going to be very very hard to deploy in an economic sense. So what's very interesting, since the Philippines is archipelagic, so we have funnels, right? We have constrictions in your islands, wherein there's going to be strong current. So what we did there, since I'm also a surveyor, we deployed instruments to measure the current profile of that. So we found that you can deploy turbines into those areas and produce energy in a more, how you say, um, scheduled, deterministic, because it is just gravitational pull of moon and the earth, right? You just gravity, and it's very scheduled. So up, down, tides, right? So that's the one of the interesting, because I know how to survey. I'm a surveyor. I go to the field. We measure the depth, measure the volume, all of those. We did an analysis, and we're able to. That's one. The challenging part there is not actually the data science part of it or the ML part of it. The challenging part, it's very costly, right? So that's because economies of scale is not yet available. That is back 2015, 2016. So that's one. Another one is whether we're going to import sugar or not in SRA, Sugar Regulatory Administration Authority. So I think back then in 2017. So the Philippines, we import sugar in some of the lean months. So what happened there is that in Department of Agriculture back then is that they we did a sort of a predictive maintenance of when to import because of the lean months, because of El Nino, because of some other factors, right? So we're able to help SRA back then. We're in, okay, maybe to build a model up to 5 years, wherein you're going to detect, okay, this area will have lean months. So maybe we need to import after 3 months, for example. And it's already predictable because you know how much yield that will be produced for that month. Then you have that. Then you import based on the consumption, demand, and supply and demand of that year, right? So you have that as well. So, and one thing is, I'll go back to the energy sector. I did a startup in Malaysia before, wherein we built ChatGPT back when ChatGPT is not yet developed. That is back in 2016, 2017. So oil companies, they spend about $1 million. I think it's a per week to survey where they will drill, right? So it's different from offshore versus onshore, right? Yeah. So it's different. I think $1 million. So what we did there is that we used all of the data sets of that company, PDFs, reports. They have all done because they're surveying it for 50 years, plus years. So we built a tool similar to ChatGPT. You upload your PDF. But back then, you don't know what's... you don't have ChatGPT. You don't have large language models back then, right? So we did OCR. We did extract all of those texts and so on. Put in knowledge and the database, Elasticsearch, a very simple tool. Then what we did is, since we have domain expertise on oil and gas, we save, so the usual oil exploration is about 6 months. So like how many weeks is that? So 4, so it's about 24, right? You have 24 weeks. 6 months to 1 year. So we're able to cut down their exploration cost by almost half. So it now became 3 months. So you cut from 1 million, the cost to 500,000. So that's already a big, and it's more accurate than, because do you know what the oil companies do when they're going to go into an area? Is that usually government has data, PDFs, maps, all of those. They give them the hard drive. They hire a bunch of scientists, geoscientists. They open the PDF one by one and read it. Then they open it one by one. And the file names, they don't have a very good structure. Some of them are just IDs. So they open it one by one, then they just note. So what we did is just a simple OCR tool. So it's not geo, right? I mean, full-blown geo, but it's related to a geospatial component that's using OCR, that's using models and so on. So yeah, those are my top 3 for now. Most of my engagements are in the energy sector. Mostly on the exploration side, not so much on the consumption side, on the distribution grids and so on. because it's more I really like the physical aspect or observational aspect of the exploration phase versus the, because this one is a little bit on this side of determining cost, supply cost, and so on. It's a little bit it adds political, economic, and so on. So I'm not well versed into that area yet. So I don't want to touch in that space. Right? Yeah. Okay. So those are top three. Okay. Finally. Okay.